Lesson 6. Stepwise Thinking. Chapter Outline. The chapter focuses on meaning of stepwise thinking, rules for drawing flowcharts, concept of algorithm, checking conditions, concept of flowchart, concept of loops, symbols used in flowchart, making the concept map. Sukaba, we are very busy today. Great! What are you two up to? First, we have to complete our computer project on A4 sheets. Then we have to cover and decorate our project files, and then we will go to market to buy project files and A4 sheets. Hold on, either I am getting confused or you are trying to play a joke on me. Don't you think you should first make a list of things to be done and then do it in correct order or steps? For example, how will you work on your project if you are planning to buy the sheets and files at the end? Thanks, Sukaba. We were not following correct steps to do the task. Let me tell you the importance of stepwise thinking. Stepwise thinking. Every activity has a sequence of steps that need to be followed. Before starting any activity, we must list or understand the various steps involved in that activity. Identify the main steps of the activity. Identify the detailed steps under each main step of the activity. Perform the steps in correct sequence. This method of breaking the activity into steps and executing the activity step by step is called stepwise thinking. The main tools used for stepwise thinking are making algorithm, drawing flowchart, developing concept maps. Algorithm. Hero's mother asked him to prepare a cup of tea following the steps given below. Step 1. Put half a cup of water in a pan. Step 2. Put half a cup of milk in the pan. Step 3. Add 1 teaspoon sugar and a pinch of dried tea leaves in the pan. Step 4. Light the burner of the gas stove. Step 5. Put the pan over the flame. Step 6. Bring the mixture to boil. Let it boil for 2 to 3 minutes. Step 7. Switch off the burner. Step 8. Filter the tea in a cup using a sieve. This step-by-step instruction of performing a task to get a work done is called an algorithm. Algorithms are used to define steps for calculations as well as processing of data. But before writing an algorithm, we must learn some basic terms. Input or read. It is used when computer has to ask for some data. Print or write. It is used when computer has to give the solution or result. For example, if we want to calculate a sum of two numbers, 20 and 32, we need to follow the steps given below to get the result. Step 1. Read the number 20. Step 2. Read the number 32. Step 3. Find the sum of the two numbers 20 plus 32. Step 4. Show the result 52. Flowchart. A flowchart is a pictorial representation of the steps to perform a particular task. In flowcharts, each step is represented in the form of a geometrical shape. Each shape represents a particular use. These shapes are connected using arrows to show the sequence of the flow of steps. Let us learn the use of each step in a flowchart as shown in table 6.1. Shapes or symbols. Name of the shape or symbol. Use. Oval or rounded rectangle. Start or stop box. Used to show the start and end of a flowchart. Rectangle. Process box. Used to show the processes or actions. Parallelogram. Input or output box. Used to show whether a data is input or output. Diamond. Decision box. Used when we need to select between two options, commonly used as a yes or a no. Arrow. Flow line. used to connect different shapes in a flowchart and indicate the direction of the flowchart. Quick tips. If a flowchart is continued on more than one pages or different sections of the pages, the flow is indicated by using a pair of circular connectors, one where the flow stops and other where the flow continues. Rules for drawing flowcharts. The general rules to be followed while drawing a flowchart are as follows. The direction of flow in a flowchart is either from top to bottom or from left to right. Arrowheads are used to indicate the direction of the flow of actions. A flowchart should have only one start and one stop box. Let us make a flowchart of the steps we followed to calculate the sum of two numbers 20 and 32. Figure 6.1. Start. Read 20. Read 32. Sum is equal to 20 plus 32. Write sum. Stop. Similarly, we can solve many simple and complex problems by making a flowchart. Flowcharts are widely used to write computer programs. Checking conditions. Sometimes, while solving a problem, the computer needs to check some conditions. This means that the computer will run the program only if the condition is true. We use if, then, else statement for this purpose. When the condition after if is true, the computer will follow the instructions given after then and follow the further steps. But when the condition given with if is false, then the computer will follow the instructions given after else and follow the further steps. This problem-solving method is called the conditional problem solving. Let us understand this concept with the help of a flowchart to find bigger of the two numbers a and b. Figure 6.2. Start. Input a, b. Is a greater than b? No. Print b. Yes. Print a. Stop. Looping. In computing, a loop refers to a sequence of instructions that is repeated until a particular condition is satisfied. Let us understand this concept with the help of a flowchart to show the table of 3. Figure 6.3. Start. Input number 3. Count times is equal to 1. Multiple is equal to 3 times count. Print count times 3 is equal to multiple. Is count is equal to 10? No. Add 1 to the current value of count. Yes. Stop. This forms a loop as the start of the sequence is repeated. Concept map. A concept map is a diagram that represents words, concepts, tasks, which are linked to each other or relate to a common topic. A concept map helps in breaking down a long list of concepts into a colorful, organized, and memorable diagram. It reduces the time involved in reading the entire content. It is easy to remember also because our brain remembers visuals or diagrams better than text. The concept maps have some common things. The theme or the topic of the concept map is written at the center. The concepts are then arranged all around the central theme by using lines, symbols, words, colors, and images. A sample concept map is shown in figure 9.2 on the topic water. Seek more. Visit to learn how to develop effective concept maps.